Let's try some more. The integral of 7x over oops, I've got my dx, that's important. Do you want me to keep underlining the pieces, or can you start to see them? X is linked to the derivative of x squared. So, let u be x squared minus 5. Then du is 2x dx. You okay if I write it like that? Year 11s, you haven't separated your derivatives before, but you can, for doing things with integration, you can.
Can you just explain when you separate it?
It's really this, right?
Yeah, I get that, but du is the, we're not really familiar with the du dx because Ms. Lou doesn't really use that, so.
What does he use? Just dashed.
Yeah.
Yeah, for this, you must use this because you will go crazy if you don't.
So is the top the original and the bottom the derivative? Is that what that is?
No.
What is it?
This tells you how much u changes when x changes. Remember, this is a rate of change.
What? Okay.
It's a gradient, right?
Yeah.
It's telling me the rate at this exact moment, how much do I go up for every amount I go across.
Oh, okay.
That's what the gradient tells me.
Okay, yeah.
So it's the rate at which u changes relative to x changing. Well, that means that my vertical change is 2x times my horizontal change. My vertical change is 2x times my horizontal change.
Okay.
Okay, this is then, I need a 2x here. So I'm going to have to change it to 2x over, actually I'm going to write it slightly differently. I want this to be u to the negative a half times, I want 2x dx to match this. But if I want 2x here and I've currently got 7, I've effectively multiplied by 2 on 7, so I have to go 7 on 2 out the front. You okay with that change, Julia? Have you even looked at it yet?
I just lost my time.
I think the stuff. There you go. You comfortable with this fraction out the front, why that works?
Yeah.
To get my 2x, you okay with that? Okay, that means it's 7 on 2, integral of u to the negative a half du. Because 2x dx is du. Okay, I can do that. 7 on 2 times, I can just do it here, right? U to the positive a half divided by positive a half. Raise the power by 1, divide by the new power. Okay, equals 7 square root of x squared minus 5. Always give your answer in terms of the original x, not the new u that you invented. Cos of x to the third minus 6 over x to the 2/3. Looks scary, but this is x to the negative 2/3, which is the derivative of x to the third. So let u equal the thing inside x to the third minus 6. So du is x to the negative 2/3 times, multiply by the new power, negative 2/3 dx. Have a go at transforming this into an integral du. Have a go. You're going to try to write this as dx. If you prefer, you can substitute the other way. You can go dx is negative 3 on 2 x to the 2/3. Oops, I missed my du. If you replace dx with this will cancel with the 1 on the bottom and you'll get exactly what you need. You can just do it straight from this if you want to, or you can rearrange for dx. It's up to you. Whichever way you prefer. You look lost.
The du, is that from the u, so they've derived that? No, they haven't.
Effectively, I've gone du dx is this. And I'm going to rearrange it so I can apply this.
Okay.
That would be this method. Do you want me to do it this way? Would that be clearer for you?
That's fine. I'll just read that.
It is new for you. I don't mind doing it multiple ways to help you see.
Wait, sorry, maybe just show me that way.
So this, okay. So, Rain, you can do it either way if you want to.
Yeah.
So, I need to rearrange this so it looks like this is cos u, and I want to have it be times du dx. Negative 2/3 x to the negative 2/3 dx. That's what I want. I already had the x to the negative 2/3, right?
Mm-hmm.
So I just have to cancel out this factor. So I just multiply by a number at the front.
Okay.
Now I have negative 3 on 2 integral of cos u du dx dx, which by my rule is negative 3 on 2 integral of cos u du. And I've substituted x into my new variable u. Why? Because I can do this integral, but I can't do that. So I just turn it into one I can do. Integral of cos is sine.
Yeah.
And then substitute back. U x to the 3rd minus 6 plus constant.
Okay.
So this is a shorthand for this.
Okay.
Yep.
I need to like read it,
Mm-hmm.
consolidate.
Take your time and think about it. It's a very important technique. You okay with that, Ben?
Yeah.
You okay with it, Rain?
Yeah.
I'm gonna sound like such an idiot, but let u equal, so that's the u part.
You
Du-
pick the thing in the middle
Yeah,
whose
yeah.
derivative is also there.
Okay. And then du dx, that's the derivative of u.
With respect to x.
Yeah.
Why? Because this is now an integral with respect to u.
Right. Okay, and then you just rearrange.
Yeah.
Okay.
You rearrange until you can substitute and get rid of the thing you don't want, so now it looks nicer.
Okay.
Now, I personally would have gone quicker. I would have gone what we had before. From here, I would go du, maybe I'll just go over here. I would have gone du is negative 2/3 x to the minus 2/3 dx, and I've already got x to the 2/3, x to the negative 2/3 dx, so I've just gone, this was straight to that. And save myself a couple of steps because I know where I'm going.
Yeah.
But this is a shorthand to get to this.
Mm-hmm.
But you can go the long way for as long as you need until you get comfortable with it. There's not a problem with that.
Okay,
Sometimes, yes?
probably a dumb question, but when you derive x to the power of 1/3, why is the the constant in front of it become negative 2/3?
What's 1/3 minus 1?
Negative 2/3.
So then you multiply by the new power.
No.
No!
Yeah, why?
What have I done wrong?
Don't you...
Have I got a negative sign wrong? Yes, I have to multiply by the old power.
Yeah.
Well spotted. So that's 1/3.
Yeah.
Okay, this number's wrong then.
That's why I was confused, because that's like
No.
the derivative.
Well spotted, well spotted. 1/3. It's because of integration you divide by the new power.
Yeah.
Okay. If it's 1/3, then I just multiply by 3, right?
Yeah.
Okay. So this is just 3, 3, 3, 3.
Yeah, okay.
Yeah, well spotted.